is antimicrobial resistance? What is antimicrobial? Is antimicrobial the same as antibiotic? What even is antibiotic?
On 3rd of September 1928, Dr. Alexander Fleming returned to his laboratory at St Mary's Hospital in Paddington after a holiday.
When I woke just after dawn on Monday the 3rd of September 1928, I certainly didn't plan to revolutionise all of medicine by discovering the world's first antibiotic, or bacteria killer. But I guess that was exactly what I did. A month in the country, morning walks, watching the textures of grass moving under my footsteps, hearing only breathing and the wind. I don't know. I felt something, noticed something. The side window, a crooked latch, rain or damp air. A petri dish, like a teacup, left too long, and a pot of jam, an island of mould, big as a penny, and around the mould, beautiful as a seashell, perfect as a rainbow. Nothing. A zone of inhibition. Something in the mould growing on the culture medium, had inhibited the bacteria, was in fact inhibiting their cell division, but all I knew was it was beautiful to me. A natural substance of unknown origin growing that could hold bugs back. Penicillin. Penicillin, grown from penicillium. As simple as that.
Excuse me, what's happening? What are you lot doing here?
Well, I've come from UCL today.
I'm coming from University College London Hospitals.
I'm from Department of Chemical Engineering, University College London.
And I'm from Great Ormond Street Hospital.
Another hospital, London, the present day. Eleanor, a healthcare scientist, arrives at a ward where Alex Fisher sits in bed, flicking irritably through a copy of the Metro. Alex had not expected to be readmitted today.
Mr. Fisher? Hi, I'm Eleanor. May I call you Alex?
Call me anything you like. I'm not going to get up and walk out.
Alex, I'm a healthcare scientist and I'm here because the test on your knee showed a positive result for infection.
This is second time.
Your surgeon, Mrs. Ahmet, told me your knee replacement has already been taken out once as a result of infection.
She should have fitted me damn knee with a zip. Look, aren't you going to examine it?
I am. We're running tests on your joint fluid in the lab right now.
Let's see.
I wanted to find out a bit more about you.
Why? Have you lost me notes?
I know the ins and outs of your knee. Very little about Alex.
I'm a fitness instructor. The thing is, I think they messed up on my knee surgery in the first place.
There's nothing in your notes to suggest that.
But how can this be happening again? I take care of myself, exercise. I've only just got back from working on a cruise to Australia. I need to work.
The history of any patient is part of our shared biological history. Humans co-evolved with trillions of microbes that inhabit our bodies in complex ecosystems, constantly adapting to the changing conditions of their host. Us, me, you. Over 400 species in your gut alone. And without bacteria, our bodies will not function. As long as we are unhurt, healthy, bacteria can cause us no harm. Before penicillin, any laceration or abrasion could be fatal. Like surgery, like Alex's, unthinkable. It's easy to look back and see penicillin as a turning on a switch, like grey infection control. I used to be called into one case of antibiotic resistance every 6 months, then once a month, to a week, and so it goes on.
According to the latest WHO report, at least 700,000 people die each year due to the drug-resistant diseases. And this could cause 10 million deaths each year by 2050 if no actions are taken.
Meanwhile, back at the hospital, our friend Alex is waiting for his test results, and they're all clear to go back to work.
Hello, Alex.
Hey, Doc.
I'm a healthcare scientist and a doctor by PhD.
Have you got my results?
I've got an initial result on the type of bacteria.
What's that? Good news?
It's good in the sense that I can prescribe you a broad spectrum antibiotic aimed at containing the infection. As soon as we isolate the bacteria, we can hone treatment, and then I can change your prescription again.
Whoa. Why do you keep changing it? Why can't you find the right one?
Because the bacteria in your knee are resistant to the antibiotics we normally use.
Since when?
We'll know more in the next 24 hours, whether it's a bug you picked up recently or an existing bug that's become resistant.
How? Listen, I never take antibiotics, hardly. For a chest infection, from a GP like anybody. I had a tooth out and, yeah, after I broke my wrist, I was on antibiotics, so about 3 or 4 times. And I always finished the course. Isn't there any chance you've made a mistake? I'm sure I'm not antibiotic resistant.
No, you're not.
I thought you said that I were.
Antibiotic or antimicrobial resistance is not something that happens to Alex or Eleanor. It is happening to the bacteria inside Alex or Eleanor. Some bacteria that colonize our body, our environment, have become resistant to the antibiotics we have to treat them, so that when Alex or Eleanor needs treatment, it's not there.
That's what antibiotic resistance is.
A particular bacteria has evolved resistance to the drugs that we use to treat it, not you.
What about my knee operation?
It's not safe. Not until we have a way to bring the infection under control, and even then...
I'm a fitness instructor. Supposing you can't control the infection, what then? Am I going to lose my leg?
Alex, I can't sit here and tell you that that's impossible. More likely you may require a clean and scrape to your joint.
Oh, God.
I promise you this. I and my team, we're doing all we can, and I'll always be straight with you, Alex. And I'm optimistic at the moment.
But I've always... I just came back in for a swollen knee.
With antimicrobial resistant bacteria increasingly common, the truth, I'm afraid, is most of it's just very bad luck.
Bad luck?
I'm sorry that you have to face this. Are there any other questions that you want to ask?
So if I've been honest, you're the first person who's explained that to me.
So that's your solution? Talking to people and being honest?
What's wrong with that? I like to have things properly explained. That's why people end up on the internet scrolling for clues.
I've been doing research too. I'm learning from experts all the time.
So inappropriate prescription of antimicrobials and easy access to them in lower and middle income countries increases rates of AMR. If you buy a drug without an informed diagnosis by a healthcare professional, there's a high chance of clinical failure. So because of this...
The wrong drug is chosen for the infection. Too much drug is taken over a long period of time or not enough. Where a patient feels better for a short time and stops taking their drugs, this can lead to a rebound infection, where the remaining bacteria that were not killed multiply until the infection returns. They may have learned how to combat the drug you were taking, leading to resistance.
Wow, you have learned a lot.
Microorganisms have an innate ability to learn resistance genes, sort of like an innate talent.
This is my house. Me and my husband bought it 8 years ago, and I haven't lived here for nearly 7 months. An A&E visit, that turned into a 6-week hospital stay, that turned into a 6-month hospital stay. I call my husband. Hiya, yeah, it's me. Yeah, I'm just back at the house because... Oh, no, she's fine, everything's okay. He thinks that something's happened to her. Every unscheduled phone call from me plunges him into panic, and I can sense the fear in his voice. I just thought I'd come back, and get some fresh clothes and pick up Fredbear, because she's been going about Fredbear all week, and I just thought that I would... Well, no, she had a 2-hour session booked in with the play therapist, so I just thought... Well, But she's not on her own, is she? She's been in there for over 7 months. She sees a play therapist every week. She knows who she is. But I'm scared too. You know, I'm hurt. I'm hurt that it's always about her. And I'm ashamed that I feel that way. That I'm selfish and that I don't exist. But I can't tell him that. So I defend my decision to return to what was once my home, to touch the things that were once my belongings, to live the life that I once lived and to feel like myself. Yeah, well, you don't always bring the right stuff, do you? I've been wearing the same goddamn hoodie for 3 weeks. And I want him to say that it's okay.
She'll let me in a minute. I clicked on the link on time, but that's what they're like, isn't it? Students got to tear themselves away from the socials. Watching blockbusters, that was supposed to be the thief of time when I was a student. I didn't watch it. I thought he was a bit creepy, that bloke, Bob. So I might be doing her a disservice. She could just be late. She could think that watching cat videos is a bit creepy. Quite nervous about this, really. I don't normally talk about it much. I mean, who wants to talk about being ill all the time, on and on? Well, some people do, don't they? Even people who haven't been ill. I got one of those give me money for something I want to do anyway requests on Facebook the other day. This woman that I worked with ages ago, she's shaving her head to raise money for Macmillan Cancer. And all these people are going, oh babe, that's so amazing, so brave, all that crap in the comments underneath. And I just thought, how dare you? How dare you? You're going to shave your head from choice and everyone will go, oh, have you got cancer, babe? And you can say, no, I've just done it to raise money for the poor, ill people. I'm fine, really. Cancer tourism. I thought it was disgusting. I quite like her as well. If she wasn't my niece, I wouldn't be doing this. It's for a life writing module at uni. She'd probably say, you're just scared of being triggered, Auntie Jen. Because if they bring something into class to work on, they've got to do a trigger warning. And it's all about abuse and stuff like that. It's on the list. She sent it to me, actually. I've got it in there somewhere. Yeah, so, I mean, it's all quite sensible, really. It's like misogynistic language and violence against women, rape, sexual assault. I mean, you know, all that. But then at the bottom, oh yeah, where is it? It's down here. After fat-phobic content, illness and death. Illness and death. One half of the world can't stop going on about it, and the other half have to warn you before they even mention it. I'd have liked a trigger warning for the pandemic. I couldn't work it out at first, like why it felt so weird. I mean, obviously, you know, it was pretty rubbish, wasn't it? But in a way, it was quite exciting as well, wasn't it? Like, we're all getting to live through this really massive thing. It's happening in our lifetimes. Well, hopefully we're going to live through it. But I kept having these, well, I suppose they were flashbacks, really, to when I was ill. I usually try not to think about it. It happened to me, I got over it, and it's done. But last year with the virus, I couldn't stop thinking about it because it was the same. The precautions were the same as when you're immunocompromised by the chemo. I was lucky. I didn't get an infection until I was on my 5th cycle. And the nurses said to me, so what antibiotics have you been on before? And I said, what before? And they said, when you've had an infection before. And I said, I haven't had an infection before, this is the first. And they said, oh, you're lucky, getting this far without an infection. You feel about as unlucky as it's possible to get. At the time, everyone was really amazed that I was in isolation for 5 whole days. And I mean, now that's nothing, is it? People have to stay in their bedrooms for double that. So, yeah, that bit of illness glory is denied me. I sing in a choir. One of the blokes is a doctor. He sent me this email when he knew what I'd got, and he said, the prognosis is very good if you get through the treatment. If you get through the treatment. I don't really know what he meant, and I just wrote it off as usual doctor stuff, let's look at the evidence here, which generally means let's be totally unsympathetic and controlling. But that is what he meant. He meant the prognosis is good if you're lucky enough to survive the infections you're almost certainly going to get. My oncologist said to me, it's really much easier if people do everything we tell them to. And I'm sure it is, for them. Anyway, I did do everything they told me to. Because they said, the controlling ones, that they were treating to cure, which was obviously lucky, but you're still frightened. You're frightened all the time. Just have to distract yourself. Which is handy because having cancer is pretty distracting. Like, the whole business of it is incredibly time consuming. I was sort of relieved to get that infection because I could just stop being in charge of it, me, the cancer. They could do it all. It was actually quite relaxing to begin with. It never crossed my mind that the antibiotics wouldn't work. I mean, you just think, oh right, I've got a bit of an infection, so the drugs will clear it up. And then they say, so your sepsis. You think, what? Sepsis? My sepsis? That's like blood poisoning, isn't it? People die from that, don't they? One night, the nurse kept coming into my room at different times and said, can I do your obs now, because we've got a bit of a crisis next door, someone's not doing very well. And I said, yeah, fine, whatever. I mean, it wasn't fine because she kept waking me up, but when someone isn't doing very well next door to you, you do feel a little bit churlish, objecting. So I saw the fire, the tower, because I was on the 17th floor in my air-conditioned room. Safe. It was boiling hot that week. So I was lucky, everyone said, to be in the cool. Lucky. Oh, she's here.
Now I think I understand. In fact, the truth is, now I understand it better than a lot of you. Behind your walls that need repairing, your leaky dams, you talk about the last line of defence. The news proclaims the war against infection. So, you think you're in a war against bacteria, do you? A war against resistance. That makes it a war against you. Against people. And if so, people aren't winning. Every year you fight harder. More and more of you rely on drugs, last resort on surgery. Surgery now is needed for things a pill cured 10 years ago. Now you're scared that we're taken over. Bacteria at your service. Does it surprise you that I have a human face? I've grown inside and been with you all the time. You've heard me say it often enough. I like to learn. I learn from you. If there is a war, you humans started it. We were on your side. A microbial army of students and assistants ready to help out. Help digest your foods, make your cheese, your bread, your beer. We rotted compost. We made soil fertile and crops grow. Bacteria took away your sick, your old, cleaned the natural world with decay and death. Until modern humans got greedy. You wanted to change the rules between us. All we do is follow orders. All we want is the same as you. To survive. We learn from you. We always will. We're greedy too. We follow your lead.
In 1945, Alexander Fleming accepted that year's Nobel Prize for his part in the discovery of penicillin. In Stockholm, Sweden, he steps up to the podium and gives this speech.
I'm going to tell you about the early days of penicillin, for this is part of the penicillin story which earned me this Nobel Award. To my generation of bacteriologists, the inhibition of one microbe by another was commonplace. Indeed, it is seldom that an observant clinical bacteriologist can pass a week without seeing, in the course of his ordinary work, very definite instances of bacterial antagonism. It seems likely that this fact that bacterial antagonisms were so common hindered rather than helped the initiation of the study of antibiotics as we know it today.
It is not difficult to make microbes resistant to penicillin in the laboratory by exposing them to concentrations not sufficient to kill them. And the same thing has happened in the body. The time may come when penicillin can be bought by anyone in the shops. Then there is a danger that the ignorant man may easily underdose himself and by exposing his microbes to non-lethal quantities of the drug make them resistant. Here is a hypothetical illustration. Mr. X has a sore throat. Mr. X buys some penicillin and gives himself not enough to kill the streptococci, but enough to educate them to resist penicillin. He then infects his wife.
Mrs. X gets pneumonia and is treated with penicillin. As the streptococci are now resistant to penicillin, the treatment fails. Mrs. X dies.
Who is primarily responsible for Mrs. X's death? Why, Mr. X, whose negligent use of penicillin changed the nature of the microbe. Moral: if you use penicillin, use enough. Okay, now we know what AMR is. What are we going to do about it?
My name is Sam, and I'm a first year PhD student, and I'm based here at UCL, where I spend most of my time over at Great Ormond Street Hospital. And what I'm doing is I'm collecting samples from the environment around patients and in their waiting areas, etc. And I'm looking for bacteria, viruses and fungi that can cause disease. And the idea of this is to build a good evidence base that we can then put to the infection control and then use it as a way to prevent people getting the infections before they do, and then we need to prescribe antibiotics. So what led me to this rather specific and niche bit of science? So I think it's fair to say that I was always quite interested in living things and biology. I remember, even when I was like 10, being one of those kids who'd look under logs to find the insects and look in rock pools. I ended up going to a university that had such a strong focus on biology, and the biology that it did was really applied. It was all kind of, how do we use this in a setting that matters? So they did microbiology, and it was quite clinical. They did cancer, and then how was that related to patients? And I found that there was one microbiology lecturer there, Dr. Worthington, and there was just, his lectures, they, again, like my secondary school biology teacher, they really captured my imagination. And I was just like, yes, this is great, I was really enjoying it, and an opportunity came along to do a year placement in his research lab. And it was looking at a bacteria called Clostridium difficile, which is associated with infections, usually in elderly patients, and could be really quite serious. And it was doing that placement where I realised not only do I really like this subject, kind of from a reading and learning about it point of view, actually doing it. And over time I learned more and more about the topic of antimicrobial resistance and how that relates directly to the application of what I'm passionate about, microbiology, to patients. And it was through various projects, such as an antimicrobial awareness week that was run, where we would do events where we would show other students and primary school and secondary school pupils kind of what bacteria, and then how did that relate to antibiotic resistance? Why is it important? What does it mean? The project I'm doing at the moment, the aim is that we will find in the environment the bacteria that cause these infections, like your MRSA, and hopefully this research is going to be able to directly influence infection control and mean that patients won't get the infections in the first place, so cutting down on that antibiotic usage that we have. And it's that direct application, that ability to take this science that I'm really passionate about and get that research and directly improve patient experience and ultimately help with patients' survival that really keeps me going.
We need to think globally. We need to learn from bacteria about cooperation, communication, teamwork. We need to support one another as a species, to share knowledge, discover where and how we make the right choices for our species and ourselves.
So imagine you are sick and you go to the hospital to get cured from your illness, but in the end you end up having an infection called an hospital-acquired infection. Just the same way, imagine taking a shower during your hospital stay and then you get infected by a bug called Pseudomonas aeruginosa. This bug is one of the most prevalent microorganisms in the hospital environment, especially in hospital water systems. It can infect your wounds, respiratory system, urinary tract, and from there it can pass to your blood. Here you see how we collect it from shower waters and drains. In culture microbiology, we see it in many forms and colors, as you see on left-hand side, green and yellow mainly. This bug is important because it has innate antimicrobial resistance properties and it can easily acquire it from the environment or from other species. On the right-hand side, we see antibiotic susceptibility tests, namely disc diffusion assay. The first two pictures show the tests of this bug against 12 different antibiotics. So the clear zones formed around the antibiotic discs show that this bacteria was actually sensitive to the antibiotic. So this isolate was taken from the hospital water. But when we check the last two pictures, we see that no clear inhibition zones are formed, and actually this bacteria is resistant to all of the 12 antibiotics tested here, which makes it multi-drug resistance, and this bug was taken from a patient who had the Pseudomonas aeruginosa bacteremia. So we can say that none of these antibiotics will be helpful to treat this patient's infection. When looking through all this, we realized some links between the shower water strains and the strains found in patients' infections. So now we are trying to make those links. And my research showed that after running the shower water for a couple of minutes actually decreases the bacterial load. Given that this bacteria affects mainly immune-suppressed patients, let's say cancer patients, if you ever end up staying in the hospital with an underlying condition, make sure you run the shower water for at least 2 minutes to have safe water.
So we have all understood that this antimicrobial resistance is a serious global threat to the modern healthcare system, which can cause a severe impact on human health. The solution to tackle this issue includes the rational use of antibiotics and development of new drugs, but that's not very easy. At the same time, it is critical to develop a strategy that can kill bacteria instantly and prevent them from spreading, such as antimicrobial surfaces. Talking about these antimicrobial surfaces, one of the components that can be used to kill these bacteria on the surfaces is gold. Gold, we all have seen, is used in jewelry. But when we go at the nanoscale, basically 10 raised to power minus 9th of the meter, the properties of these gold particles changes drastically. So you all have seen gold, but these are the gold nanoparticles, and they exhibit different colors when they are in different sizes. So these are the particles that we use to immobilize onto the surfaces. These ultra small gold particles are known to exhibit antimicrobial activity, and they can ultimately kill the bacterial cells. These surfaces can be used in healthcare settings, in coatings. The thin film of the prepared antimicrobial surfaces can be coated onto the surgical and implantable devices to kill the bacterial cells on the spot. Apart from this, it can be incorporated onto the various fomites such as doorknobs, railings, clinical trays, keyboards, tables that are frequently touched by the number of people. So basically, rather than we can prevent the bacteria going directly to the patient on the before itself. So in this research, we have developed these gold particles that are attached onto these brushes, which are polymer chains, looks like that it's in the hair brushes, to a surface by one, and the same fashion that bristles on a brush are connected. The method of the attachment will prevent the detachment of gold, because we don't want gold to go away when it is being touched. And then these surfaces were also tested with two types of bacteria, E. coli and S. aureus. And what we see in that most of the bacteria was killed within an hour of the reaction. So these antimicrobial surfaces will kill the pathogens on the spot, thereby helping in preventing their growth and spread. This can be also a step forward in combating the problem of antimicrobial resistant germs.
So, let me ask you 3 questions, okay? Number 1, do you remember the last time that you had an antibiotic? Number 2, do you know if it was the right antibiotic for what infection you had? And number 3, do you know if you actually needed it or not? Now, research shows that in 7 out of 10 of those cases, the answer is no. You probably didn't need the antibiotic, or it probably wasn't the right one. In some countries, you can actually just go and buy antibiotics in your local equivalent of Tesco's or Sainsbury's or whatever. You walk into the shop and you say, let's have some penicillin, please. And they'll go, yeah, £1.50, please. You'll take that. What happens is, though, if you take that penicillin and it doesn't kill all of the bacteria, you get something like this happening. The bacteria that survive, they learn, they remember. They're like, hang on a minute, we know how to fight this now. So you get an image of what looks like a guzzling bacteria. What's really cool is as well that a lot of the drugs that we give to animals are actually the same as the ones we give to humans. So if you go to, say for instance, your vet and you get some drugs for your dog, and you go to your doctor and you get some drugs for yourself, some of those are actually identical exactly. So this is the way that AMR, antimicrobial resistance, can actually spread. So if you take a drug and you develop resistance in a human, in yourself, or if the same thing happens to animals, you can actually now pass these resistant bacteria backwards and forwards between different groups. So from animals to yourself, say for instance your dog gives you a nice sloppy wet kiss in the morning, but he's got some nasty things on his tongue. That can be antibiotic resistance, that can be spread to you. If you go into a local supermarket and you pick up some vegetables that have been contaminated, that's a way that antibiotic resistance can spread from the environment up to you. Now what's really cool about bacteria is they're tiny, tiny, tiny things. We can't see them. What they do is they have this genetic code called DNA. It's like the building blocks for life. When they develop resistance to an antibiotic, they can then take a little bit of this genetic code out of themselves, package it into something called a plasmid, and then hand it off to somebody else, or in this case, another bacteria. So this bacteria says, I made this, here's a plasmid. Gives it to this other bacteria takes it in. Now this bacteria has also made that plasmid and can spread it on to other people. So what my research is trying to do is figure out how these plasmids, how this resistance is spread between different types of bacteria in humans, in animals, and in the environment. So unfortunately I couldn't give you a sample. We take bacteria from poop. So I didn't think that would be very nice to bring into it today. But anyway, we take a very, very small stool sample, we take the bacteria from this, we dissolve it and we run it through a fancy machine. This gives us that genetic code, these building blocks for life. And what we can do is we can then search for the plasmids and then do some sort of trickery down the line and try and figure out, is it animals that are giving you the most resistance? Is it humans giving you the most resistance? With our limited resources, we can then design interventions which will specifically target wherever this resistance is coming from. And the goal downstream is to reduce the amount of antibiotics being used, reduce the amount of resistance being propagated.
Be careful about the usage of antimicrobials. And if each of you tells other people you come into contact with what we have said today, that will make a difference.